This is the
So I think this is your model, right?
yeah, this is the old model.
So we will work on this model. Correct.
Yes, we will work on this model to convert it into continuous bridge.
Sorry, I cannot hear you, brother. Your voice is very low.
It's very low. Now it's okay.
Okay, okay.
Yeah,
Yes. So
we
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 will
will
work on.
convert this. Yes, we will convert this into continuous beam as in the PDF file you see.
Mhm.
Yes.
Yeah. So what
Yeah.
is the length that you want this one to be? Like, okay,
Uh,
okay. This
yes.
one, the one in the middle, we can delete, right?
Yes, the middle one we will delete, and the span, the span we will use plus 52 meter, and the middle span will be 80 meter, and the another will be 52 meter, as in the older, uh, seen in the older, or the model on the thesis. You see,
Mm-hmm.
can you open? Yes, this is the more. Can you see?
Uh, yeah, see the pictures, but I did not see any dimensions they put.
Yeah, there is a dimension ups. I think so.
This is no numbers.
No, the number is little bit confused. I can
What
go
chapter? Okay,
in
let me
chapter
go.
4,
4, chapter 4,
page number 35.
35.
Yes, page
Okay.
number 35.
Oh, 35. Mm,
The thesis 35 page, not on the right side. Yeah, this is 15, 16.
36, 35. This is 35.
Yes, huh? Up.
Oh, okay.
This.
This one.
Yeah, yeah. Yes, yes.
Yeah, so I saw this one, but I did not see the pictures. I mean, the dimensions.
Can you down? I will show to you. Uh, yeah, stop. Let me check. You can just go to 34 page.
Okay, here. This is great size.
Yeah, oh, up,
Uh,
sound, up. This is the
great size.
dimension. Yes, this is the dimension. 52 meter plus 80 meter and 52 meter.
Okay, so let me try to understand this correctly. So we have, wait, let me show the guy again. So
Ye-
52 and then 80 and then 52.
Yes.
52, 80. Okay. All
Yes,
right.
for
Thank
the
you.
pair and for the pair and pile cape, we will use the old paper like I send you the SCI paper.
Mm-hmm. Yeah.
Yes, like pair dimension, we will use 6 meter, 3 meter, and 16 meter height.
Uh, can you repeat again? 60?
Do you have the old paper? Can I send you the screenshot?
Wait, let me see. Because I have so many things from your side. I do not know which one is the
Uh,
paper. Not this
okay,
one.
okay. Let me. Yes, the non-linear
This
paper.
this one? No.
No, this
No,
one, no,
no.
non-linear analysis.
Of
This is the.
nonlinear finite element? This
Just
one?
ups
No.
down the paper. Just up down the paper.
This one?
No, not this one. No, no, this
Um, I know this is like guidelines.
this is the guideline.
This is like a thesis also.
Yes.
Uh,
Not you know the non-linear dynamic behavior analysis, non-linear dynamic behavior analysis of bridge pair
this,
impacted to a moving barrage.
yeah, this is the one.
Yeah. This one.
Okay, all right.
So I suggest that for the pair and pile cape and the remaining, we will follow this one paper, or
Okay,
maybe the old model, more old model dimension is also perfect, but we will reduce the pair size because as compared to the uh, bridge deck beam.
okay. Okay, so let me check this one. Uh, so here also from this view, you want to follow this one as well.
Yeah, we will follow the remaining dimension of it because in the thesis they didn't mention the dimension of peer halting,
Okay,
etc.
okay. So just to confirm that I understand you correctly. So we will follow this one, this
Yes, we will
figure
follow
here,
this one.
but
Yes, yes,
the length we take it from the span, we take it from the thesis. Is it correct?
yes, yes,
Okay,
yes. Yeah, I think it will be perfect. See, in this the pair is rectangular.
mm-hmm. So you want
Yeah,
it
and
to rectangular. It
yeah,
is.
in mine, yeah, in mine this is the square. So I mentioned both that I will take the maybe I will take the rectangular pair or maybe I take the square pair. I just defend my proposal with that statement.
Mhm. Okay,
Yes,
so right now, we will follow this one, right? We make it rectangular,
yes,
and then for the span, we take from the thesis.
yeah. The span
Correct.
is yeah, the span is continuous.
Okay.
Mm. Maybe for the piles. The piles also I think so. The pile the use the see the pile
Yeah,
the old dimension is also perfect. The my old model dimension for pile.
you mean this one?
Yeah, the piles.
Mm.
Yes, yeah. This also I think also best. Is
Okay.
yes.
So how about this bridge? The girder should be the same. It's not that important, right?
Yeah, the
This
garden
one.
the girders will be the same.
Okay. So I will do it now, and you will follow me. I mean, you watch how to I do it, or you want me to do it later?
Yeah, I will follow you. I will also learn.
Okay, so all right. So we will do it, and then we will follow this one. We just want to make sure the dimensions are the same.
Yeah, the remaining parameters like velocity etc are can be done
Mm.
from old model, but we have to put the final deck load on the pair and also uh, the ship cargo weight as I previously discussed with you. You remember?
Okay, all right. Uh,
Yes.
because right
Yeah,
now
because
the velocity is already defined. Uh,
yes,
and the mass also. I want to check the mass because
yes, the mass.
your Chinese friend did like okay job. I mean, he even if you pay him, I say that he did not cheat you. He did like okay, acceptable job. Uh,
I didn't pay
oh,
for him.
oh, he's very nice guy, free of charge. Okay, so here.
The ship is also very my supervisor told me that the ship is very short, you mean very small, so as compared to the pair size, you know, in the real time accident you can just see that the ship is very large and the ship
Mhm.
the pair is small.
Okay.
Have you seen the real time accident
Not really.
in
Uh,
pictures? You can see in pictures
yeah. But anyway,
like
we can just proceed with what we have right now, and you can follow the length of this one. Okay.
yes, this
So
is
you can
okay.
see this is 3 meters, and the ship width is 11. So it's
Yes,
larger than this. So we can just follow this one. Okay.
yes,
Uh,
like
uh
the pair dimension is 6 meter length and 3 meter breadth and 16 meter height.
the what? The pair.
Length is yeah. Yes, yes.
The length is.
The length is
Oh,
6 meter.
yeah, it's written here.
Yeah, yeah. You see that the length is 6 meter
Mm,
and the breadth is 3 meter and the height is 16 meter.
yeah. Okay. Mhm.
Now
So
our target is to damage the pair and damage the
yeah.
ship
Mm,
to collapse to collide and just
yeah.
yes. My bro, my supervisor is very strange guy.
Mhm. Okay. I hope that you finish and get rid of him very soon. Okay. So I think we cannot use this file and this one, this foundation and this sphere, because I think the dimension is different. So what I will
Yeah.
do, I will just draw everything again on this model. Okay.
Okay. Okay.
So here we have, this is the cap. Do you have any idea about the dimensions? Because we only have the height here, right?
The pile cave dimension, yes, I have there. The pile cave dimension
Oh, it's
is
here.
length is 13 meter.
Yeah, yeah, it's written
Yeah,
here.
yeah, yeah.
Yeah.
Yeah, it's
Okay.
mentioned.
And 13, 3, and 10.
Yes,
Uh,
and the old one is like 23 meter and
yeah,
32
yeah,
meter.
it's very big
It's
compared
too big.
to,
It's
yeah,
too big. It's too
yeah.
big. That's why supervisor got a lot of
Okay.
change.
All right. So what I will do, I will just try the easy way. I do not know where is the location of the 000, so I can do here, uh, 2D measure, and then I will just use this tool to first draw everything.
Okay,
I
bro.
can just click and make the circle or the rectangle, or I can just put in the point. Okay. So what I want to do, I will just delete everything, and then I will do again.
Mhm.
What was it? Key in, and then we have 3, and this dimensions is 10. This is 10 or 13.
The pile cape.
Yeah, this length, you see my mouse, right?
Yes, this is the length 13 meter.
13. Okay, so it start with 13. Okay, just 13. Okay, so we have 3 and 13.
Yeah, have you seen in the PDF 13 meter? See?
Yeah, yeah,
Yeah, there is
because
the first one is the length and the second one is the breadth and the
oh
third one
yes,
is the yes,
yes.
length, breadth, and height.
Okay, okay. So here I will just say 0, 0, and then here is 0, and then this one will be the length, which is 13, uh, 13 meter. Oh, sorry, my mistake. Delete, delete, delete. Key in, this is 0, 0. Here is 13, the length. Create. Okay, so here is the line. Maybe it's a bit small, you cannot see it. Okay. And then here, the second point, it will be 13. And then we go up 3. We go up 3 meters. Create. Okay, now I can zoom in. Setting the grid spacing, maybe I make it 1 meter. And then I go back again to the lines tool and I can just click here and click here. Okay, so this is the, what we call it? The bridge
File cape.
file clip. Okay, now directly I will do this one. This is 6, 3, and 16. Okay, so here is 6. The length
The six
is 6.
meter, the 6 meter is the length.
Yeah. So let me zoom in again. Uh, this is, how much was it? So I need, here I have 13. It's a bit tricky. So what I can do, I can approximately, wait, I can draw this one first. I can make the cape first, the file cap. Here, I go to this edge,
Yes.
create, create. I make it green because when I make it green, now I can control the size. And then the size, I make it 50 mm. Oh, too much. Half meter. Okay, this is acceptable. So the element size half meter and then apply. And then I go to this tool and then I go to here and then create. Okay. So now I have created only 2D. Okay, you can see it is 2D.
Yeah,
Next
this is
is,
today.
yeah, make it 3D. So actually there is more than one way to create. So I was actually thinking what is the best one. This tool is easy for you to understand because we start from 2D and then we end up in 3D. But what I will do next, I will just create the pier from this tool. Okay, mesh, shape, measure, box, solid. Okay,
Yes,
and then
yes,
I know the dimensions. The height is 16. This is the pier. Okay, and
yes,
we have 6 and 3. Here 6 and then 3. Element size again, maybe it was, we try this one, 0.25 meter.
uh,
Create.
the the element size you can copy from the old model.
Okay, so let me create this one first. Okay, let's see your old model.
Yes,
Okay,
yeah, because the old warden is make by everything perfect.
okay, the thing is, the old model is 1 meter, the element size, but the span or the length, the height is 36. But
Yes,
in our new model, the height is
okay,
only 16. So the element size also need to be smaller. Understand?
okay, okay.
Okay.
I got it.
All right. So here I was saying, we can just create everything, or I can directly create the pier from this tool. Okay, this tool, mesh, shape measure. Okay.
Yes,
Next, I will create what we call it the cap. Okay,
yes,
so the cap has the height is 3, right? So
yes.
what
The
I
pipe
can
shape.
go, what I can do, I can go from element generation and then
Yeah.
solid and then
Do you think?
thickness.
Yes. Do you think that the pile cape and the pair, the dimension is correct as per the model?
Uh,
It will be perfect.
We can exactly follow these numbers here.
Yes, yes, yes.
Yeah.
Mm,
So that's
I'm
what I
asking
can tell
about,
you.
yes, yes. I'm asking about your experience. Is the dimension the as per your experience is correct as per the paper?
Uh, okay, you're asking about your old model.
Yeah, the all model dimension regarding that your experience, what your experience says, because you are also expert.
Okay, as I mentioned, I'm expert in meshing in the software. I'm not expert in bridge. I'm not bridge engineer.
Yeah, you are not bridge engineer, but what your experience says,
I don't understand your question. My experience in what?
your experience in the dimension,
Yes,
what your experience in the dimension says.
in the dimension size.
Yes,
Do you mean the element size?
yeah, the element size, the all bridge dimension, what your experience says.
Mm, okay, as I mentioned, I cannot comment much about the bridge model. Okay,
Okay,
I
okay,
follow the papers. Okay, because
okay.
whatever I do, the papers here, those people in are the expert for me. Okay,
Yeah,
so
yeah,
I just follow their examples. Okay,
okay, okay.
uh, so can we proceed?
Yeah, yeah, yeah. We can go.
Okay, so I go to here, mesh, element generation. I want to create a solid, and then I want to drag this bottom, the bottom of the pier, and drag it in three thickness 3 meter, drag in the negative Z, and maybe I make it 6 size of elements, and then no, not 6. Uh, it was 6, 9. Mm, okay, so I create this one. So here the yellow is the pier is okay. Now this one is the cap. So I need to extend it from or make it a bit wider. So I
Yes,
use the same tool, element generation, solid, and then from here to here is how much was it? It
the length.
was it was 6. Okay, it
No,
was
this is
6.
no, no, no. This is the pair. The
Yes, I
middle one.
know. Yes, I know. It is 6. I want it to be
Yes,
13.
yes,
Okay, so
yes,
I need to add like how much? 6, 7. I need to add 7 from both sides.
yes,
Okay, so here I need to add 7 divided by 2, 3.5. So here should be 3.5. And this one I put number 10 because the brown one is number 10. And then I drag in the negative x like this. And then
yes,
I do again here. And maybe I yeah, just keep it positive x. All right. Now you can see from the side view, this one is okay now.
yes.
From
It's
here, the
now
length
the length is
13.
13 meter is okay.
You can see 13. Okay,
Yeah,
so I
13
think
meter.
you get the idea of where I'm going. Now we
Yes,
do the same thing. Here it is 3, the width. Now I want to make it 10. So I have to add 7. So again 3.5, 3.5. So from here to here, now I will drag in the negative y and part ID number 10. And here also part ID number 10 and drag in the positive y. And now we have done with this one.
yes,
Okay.
we will do this one. Yes, yes,
All
yes.
right. So
All
next,
right.
sorry.
Yeah, yeah. All right, all right, all right, all
Yeah.
right.
Okay. Mm, reinforced pile cap, pile foundation, 2 meter in length. Okay, so this is the foundation.
Yeah,
So
this is the
for
phone.
foundation, 2 meter in diameter. So you try to do 2 meter in diameter and see how big it is.
Mm.
Uh,
What about the old one? Old one is good or not?
that one should be very big, actually, I think. Yeah, F4 to measure 2.15, 2.15. So
Yes,
it's slightly bigger.
slightly bigger.
Yeah, and
Oh,
the length is 32 meter for the old
yeah, the length
model.
is 32 meter.
Yeah.
Yes, for the old model.
So I think we keep with this new model. So here rename, I call it here. Here I rename it and I call it what? Foundation or
Pipe
cap.
cap.
Okay. Now I will try to make cylinder solid
Ye-
radius 4. Sorry, radius is 1, length is 16, and the direction is negative z. We try first. Oh, it's very big. I mean, it's very fat.
Mhm.
Bottom view, I
This is
can read
you put the radius 1 meter and the paper there is 2 meter.
the paper says it is diameter.
Yeah, and 2 meter in diameter. Yes.
Yeah. So radius 1 meter should be correct, right?
Oh,
You with me?
yes, yes.
Is it clear, right? Yeah.
What the element size you can copy from old model?
Okay. Again, I said this old model, the size is different. The
Okay.
size is different. So
Yes.
the length is larger, and also the thing is the diameter is a bit larger. So it's better
Okay.
we make a new one.
Okay.
Okay. So we have how many? One, two, three. We should have nine, right?
Yes.
Nine foundation. Okay. So this is one, and we look from the side. The position, maybe I can make it first. I make it -3, so that it starts from here. It starts from here. Here I make it 20. Okay, and now I go to accept. All right.
The nine will become perfect. The will become fixed.
Uh, we will position. We will position it later. Okay, I
Okay.
mean the next step is to make it in the correct step.
Yes.
Okay, bottom. Okay, so here I click on this one, F4. I measure from here to here. So this is the XYZ distance, 3.5, 3.5. So first I want to copy it to here. Okay, I want to make it in this corner.
Okay.
The reason why, because when it is in the corner, it will be easier for me to uh, put it in the correct direction because I know the length. So here,
Okay.
part, select this part number 11 and then move negative. So it is here. Okay. Now we have the length is 13
Yeah, the length is 13 meter.
and here is 10. Okay. So
Yeah.
13, we need to divide it by 4. 1. Okay. So here 13 divided by 4. This is the
3.25.
yes. And then here I move in the X direction only. Click by part, click this one, move like this. Okay.
Mm,
And now make a copy. I need to make 2 copies. I already have 1. I need 2 more in the X direction. Select by part, click on this, sorry, click on this one, and then click this translate positive. I have 2 here. Okay, now the same trick in the Y direction. So I have 10 divided by 4, 2.5.
2.5.
So here will be 2.5, and then click on Y negative, or sorry, positive,
Yes.
and then I need to reposition this. I don't need the copy anymore.
Yes.
Click here and then positive, and now it is perfect there. Okay.
Mm, okay. Yeah. Yeah.
Mm-hmm. Okay, maybe I need to increase the element size here.
Yeah. The element size we will to increase.
It is maybe it is too small. So I can
Yeah.
go here, mesh, shape
Element
measure,
element
shape
size.
measure, and then I will go position, and then select node and select this one in the middle here. Okay,
Yeah.
and then
Yeah.
click on done, and then direction positive Z, and then I create. Okay, I already created. You can see here. So what I will do now, I will increase the number of elements. So here I will increase the number of elements here instead of 8, maybe I'll make it 16. And here instead of 20, maybe I'll make it 40. Now if I look from the right view or from the front view or side view, I will have something like this. Oh, okay, click here. Now you can see this one is much better. So I think we can
Yeah.
accept this one.
Yes. Yeah. Yeah.
Okay.
This one.
So now we need to do the same trick to make the rest of the files by part. Click here, make a
Yeah.
copy, 2.5 in Y, it'll be negative Y. Okay. Mm-hmm. Is it correct here? Okay. Wait. See, it doesn't seem to be correct actually.
Is it any problem?
Maybe the calculation is not correct because you can see the gap here is too much, but here is small. You get me right?
From the left to right.
Yeah, you can see here is like big, here is small. So I
So.
think, yeah, so I think this is not correct because it should be evenly spaced.
Yeah. Because the can you just look about the old model? What we follow?
Even the old model is a bit different. 9 to 3. Okay, I think I will move it a bit here. in a bit here. Transform, no need to make a copy. Select by element, select this one. I will make half of this 1.25. No, this is too much.
Can we look about the paper? We will just see the diameter length is shown in figure 1.
Yeah,
It didn't mention,
yeah, I didn't mention.
but they just mentioned. It didn't mention right here.
Yeah, because here from this to this will be 5. From here to here is 2.5, correct. Okay. So I have from here to here is 5. Okay, half of this span is 5. And then minus here is 1 and here is 2 minus 3.
2
So the
minus
distance, because minus 3, which is I'm considering the diameter. I'm considering the thickness. Okay. So here it should be only 2 meters apart. 0.25, 0.25. Like this, by element, and move positive. Mm-hmm. 0.5. Okay. Now it looks much better. Right? Now it looks much better.
the box 1, 2, 3, 1, 2, 3, 1, 2.
The element size is a bit different. So it's hard to
Mm,
measure like that. We just measure from here. Okay, from here to here is 1 meter. From here to here is 1 meter. And from here
uh,
to here is also almost 1 meter. So I think this should be acceptable.
yeah. So in the old model, the difference, the mm, the spacing between pilot cape is about how much? 2 meter. In the old model, they just 2 meter. So
No, in the old model, it's more than 2 meters. You can see if we consider the diameter, it's 3.75.
yes,
If from center to center, it's 5.9. So it's
yes,
completely very bigger.
yeah, because the pilot cape is also bigger, you know.
Yeah. So that's my point. It's not actually it's not meaningful to compare with the old model because
Yeah,
the old model is very large size. So, so here is rename files. Okay, now we need to make the same thing for in this direction. So here it was first I need to make the copy as it is 3.25 by area, select elements by area like this. Just hide this one and then 2 copies in the x direction, negative, like this. Okay.
Yes. Okay.
Yeah, now you can see the distance is not the same. So here, again, the whole length is how much? 13.
13 meter.
Yeah, and here I have 2 and 2 and 2. So 13 minus 6,
It's about 7.
7. And 7, I need to divide it into 1, 2, 3, 4. So 7 divided by 4, that'll be 1275.
1.75.
Yeah. So here what I want to do, no need to make a copy. 175. And first I will make this here like this, my
Hide the
element.
hide can hide the pancake.
Yeah,
Yeah,
like
it's
this.
not.
And then move back. Oh, sorry.
No, reject
Uh,
direction. Why?
okay. So first I will move back to make it in the center. And then I have this one.
And then
And
okay.
then consider the diameter, half and half, maybe 2 should be. And then uh, positive. Okay, so I think this makes sense now. So again, I repeat for this one. Here I will make, how much was it? 3, the origin 3 to 5. 3 to 5. I back to the center and then 175 and then add the diameters. Okay, now it is perfect.
Hmm.
Yeah,
Hmm.
control safe. Okay, so this one, the pier and the cap is already connected together because you remember we use this element generation tool. So it is fixed together. Now I want to fix this one and this one. Okay,
Yeah.
the piles and the cap. So from here, I need to go to keyword and then contact tight surface to surface. Sorry, contact tight surface to surface. And then I will put number 10 and 12, new ID. So files and caps.
Connection.
Yeah, connection. So they will be like perfectly bonded. So here
Yes.
I will put ID number 10 and ID number 12. And then click on accept. Done. I click on save. Now I go to model check, contact check, tied. I have this, okay. And then click on check. You can see here 355 of the nodes are tied together, or the green
Yeah.
one. Yeah.
Yes.
So these green nodes are tied together. So
Yeah.
here is 355. So if I want to remember 355, if I want to switch this, let's see how many nodes accept. And then I
Then
go to model check again. And this is the same one. Check. Okay, now you can see 657, which is better. So it's better
hmm,
to make the second option. Okay. So
okay.
these nodes, if I hide this, oh yeah, it will still be these nodes, the green ones will be fixed, will be the points where the two parts are fixed. Okay.
Hmm.
All right. So here I need to save. Okay, we are done with this. Uh, Next, I want to make this the bridge deck, which is this one rubber laminate the rubber bearing 2 by 1 by 1. So we'll make this rubber bearing. Okay. So
Here's
the
the rubber. It's
yeah
2 meter, 1 meter, and 1 meter.
yeah. So how can I make this first?
Model.
Yeah, I'm looking for the best way to make it. Okay.
Okay.
So here, let me from the top view, and I only show the piers. So here I want 2 meters like this. Let me, this is 1.5. Okay, so great. This is 2 meters. And from here to here, hey, wait, the length is 2 meters. Sorry, my mistake.
The length is
The
two
length,
meter and
yeah. Oh, it's very small one. Is it? From here to here. Okay. From here to how many? 4 elements here. So 2 meters. And then I click on F8 and I will hide this. F8 is the blanking tool, meaning I will hide.
okay.
And from in the Y direction, it's only 1 meter. Click on F4. So it'll be 4 elements like this. Okay.
And
So
hide and
I click on F8 again. Hide like this. Hide like this. Okay. Now I will go to element generation. Thickness is 1 meter, right?
yes,
Segment, maybe I'll make it 1 first and see how does it come to be. Okay, I need 4 segments. Okay, so the green one is the rubber. Now I click on F8, unblank all. So I have this one now.
yes.
Okay, so this one
And
is, they call it bearing.
bearing
Rubber,
head.
yeah. Okay, so now from the front view, we have like this. From the side view, we have like this. Okay, now here, the bridge deck. We do not have any details on that, right? We only have the height.
Yes.
Okay, so what I can do, the only thing, okay, he did some, okay. You want to see the deformation in the bridge, right? Or in the
Yes.
bridge and the ship also.
Yes, in the ship and the bridge. The
So,
formation to completely damage the pair, to destroy.
okay,
In the real-time accident, the bridge totally collapsed when the ship
yeah,
collide with pier. So
okay,
something like that.
okay. Here, he did not give some details on
About
on
what?
this about this.
This
I
is the
mean,
ship. This is the ship size.
yeah, he did not give enough details. But anyway, that's okay. We proceed one by one. We want to make first the what you call it, the bridge deck now. Okay. So since we do not know anything about here, dimension here,
Mm,
I can
yes.
assume this is 1 meter and this is 2 meter. Okay, and
Mm,
this the same length. Okay, here and here the same length. So you get where I'm pointing, right?
yes.
Yeah.
One thing I'm going to explain. In the
Mm.
previous model, my supervisor have you seen in the comment of my supervisor that the pair and the beam size is not correct.
The beam, the pair, the beam,
Size
this
is
one.
not, yes, the beam and the pair size. Let
Okay.
me explain his comment to you. He told later, mm, he said that your bridge is too big and the span is too short and the boat is too small. And I hope you have an idea how big the bridge and the boat are to each other. So, and he explained that the bridge pair are much larger than the beam, which is abnormal.
Yeah. Yeah, this one is larger than this.
Yeah, so
But
we have to
here also the same. You can see this one is larger.
exclude this mistake.
So what will be our reference then?
Hmm?
Yeah, you can see here also is bigger.
Yeah, here is also bigger.
Okay. Uh, so how to proceed with this? Because according to the papers, this is correct.
And the paper, according to the paper, this is correct, right? You are right. You imagine in the thesis I sent to you.
Yeah. Mm, yeah, you can see this one also, the bridge deck is looks larger than this one.
Yeah, in the thesis you can just go to about the 41 page and see.
31 page. Page 31.
41, 41, 41.
Mm. Yeah, you can see it's also wider.
So,
So all the places that we check, it is wider. This
mm,
deck is wider.
yeah, this is wider.
Page and here. So you can see also the picture. You can see it's all wider.
Yes,
You can see this is a real one. You can see the deck is wider. Here also the deck is wider. Here also not close, not not visible. Yeah, here also is wider.
yeah, we will like that is okay.
Okay, so we just follow this one then. Okay. So first, we hide this.
There will be some connection between the bearing pad and the pair or not?
These two,
Yes,
it is connected. It'll be
connected.
connected because we use this element generation tool. Okay.
Okay,
When we
okay,
use this element, this tool to generate the new elements, it will be connected. But
okay,
if we use another method, maybe it will not be connected. Depend on the
okay,
method. Okay.
okay.
So here from the right view, what I can do, I can from here to here measure. We want 3 meters, right? So from here to here, no. Okay. So from here to here is 3 meters. It is what I want.
Mhm.
Yes. So what I can do, I can go to transform, reflect, reflect normal to Y, normal to Z, pick the origin, is somewhere here, and then I will pick the elements that I want to reflect. So here you can see I pick this portion. Now I make a copy and then reflect. Okay. So now, of course, I have some additional elements. I just need to delete them. Or no, I need to extend. Need to extend to the side. So here again, this one, before I proceed, I go to move copy. I put number 14, and this, we call it deck. By elements, area. So here I will just change the ID. So it become yellow. Okay. So now I will extend to left and right. So here is how much is 3.5. So I will extend 3 meters here and 3 meters here. Okay. And here I need only 4 elements. Here also I need to show only 4 elements. So I go to F8. I will hide this and I will hide this. And then again, I go to mesh, element generation, solid, in the X direction, uh, thickness is 3 and for maybe 12. And then in the positive X, and here part ID maybe 14 also. Click here and then create, and I have this. Now again, I go to this side, click here, and then part ID number 14, negative X, create, done. Okay, next I will click on F8 on blank. Okay, now I have this deck. Okay, now everything is connected except these two. Okay, the deck and the rubber band are not connected. This is because I use the element translation tool. Okay, so to connect between these two, what I can do, I can go to duplicate node, show duplicate node. You can see the nodes are highlighted.
Mhm.
The nodes are highlighted. So these nodes will be fixed together. Okay, so click on merge, accept, and we are done. Okay, so here the bridge, it's empty inside. We can delete that later, but I just want to highlight. It looks empty inside.
Yes,
Well, I don't know if there is any pictures here. Yeah, not visible, but looks empty
yeah,
inside. Yeah, the same like here. It is empty inside, but I'm not sure how to do to follow what? Because we do not have any information about this one. But we can delete it later if we want. That should not be a problem. What I want to
Okay.
do next, want to create the span. Okay.
Yeah. Yes.
So to do that, I need to see the span. How much was it again? Just to make sure we do not make mistakes. How much was it?
You can go to the page
Fif-
number. You want to know about the span?
Yeah, was
52 meter,
83.
52 meter and 80 meter in the mid. Let
Okay.
me
Yeah,
tell
I
you the
found it already here. Okay. So 80 meter. Now is the question here. Is 80 meter from the center of the pier or from the side?
uh, the
Yeah.
side the center distance is 80 meter.
Okay, so here I click on front view. So from center to center is 80 meter.
Yes. Um, the 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 distance between two pair is 80 meter, and from another side is
Okay,
50.
brother, I understand. My question is, okay, the 80 meter, I will measure from the center here or I will measure from the edge here. That's my question. You understand?
Yes, I understand.
You get
But there are,
my...
yes, I get your question. But have a look about the thesis. What he say?
Okay. I think we can... Oh,
They just mentioned the example, the Gwangju Bridge.
yeah.
See, they mention also the pair.
Yeah, but here is a different case.
Yes.
Okay, anyway, since we do not have information on that, we will assume that it is 80 from center to center.
Yes, 80 is from center to center.
Okay. Since you also do not have that information, I will show you how to do it, but later on, of course, you can edit if you want. Okay. So here, translate in the Y direction and 80. Okay. So click here by part and click all of this and translate positive. Oh, sorry. Need to make one copy. Translate positive. Okay. So I have this. Now I will measure. Click on F4. Zoom in from this point to this point. Okay, the distance is 77. So I
Mhm.
need to connect now. So here I go to element generation, thickness 77. And here I will make it first 77 and create solid part number 14 because it is the deck. Select elements and propagate and click here and then in the positive Y and create and then accept. Okay, so now we have our bridge here.
Mhm.
Okay, I will.
The will cause any problem?
What do you mean? What
The
problem?
the see in the did we create the joint in the left side? Yeah, in this one.
Yeah. Yes.
Yeah.
I'm using this duplicate node. Now it is connected.
Yeah, it's connected. Now it's okay.
Yeah, no, it's okay.
It's okay.
So
Okay.
here, from here to here is 1.5. Okay. So here it is 52. So from here, I need to extend, make it 52. 52. Uh, oh, okay. Oh, wait. 52. I will drag this one first. Select, sorry, propagate, select the element, click. Oh, click here. And then part ID number 14. And here also, part ID number 14. And make it negative. Create, done. Okay. So this is done now.
Yeah.
Save.
Duplicate node is okay.
Yeah, it's okay. It is connected.
Yes. Now we have to put the steel.
Yeah. The steel will be very tedious job. So what I can do, I can take it from the old model and try to resize it, because that will be the faster way.
But the old model is pair.
Yeah.
So it will be done.
Okay. No problem. I can work it out. We can just change the dimensions. Okay, from here I need to look from the right view. Okay, I have this reinforcement. I only need one of them. Okay, so I need only one group, and the next I can just copy. First, I delete like this, and also delete this. Okay, now what I want to do is this one is 8, and this one is 8. We have 8 and 8. Here we have 3, and here we have 6.
Yes.
Yeah, 3 and then 6. Okay, so first I will scale this one to make it smaller. First, I go to node edit. I will create a node in the center here. So advanced node, and wait. Before I scale it, I will just I can create the node at the center because I need that. Create a node by average center by area like this, and then compute, apply, and then accept. So I have a node here at the center. Okay, so this node will be a bit important for us. This node ID is this value, this number. Okay, this might be important. Now I will rotate everything. Okay, so first of all, click by area like this. Oh, before translate, I rotate like this. Rotate in the X direction. This is the center of rotation, which is the center of this part. Rotate in X 90 degree. Okay. And then, yeah, I need to do some. Okay. This is 30 diameter, right?
Yeah, 96.
Wait,
And 96 is the number and 30 is the diameter.
so 96 is diameter 30 and the
Yeah,
distance
diameter
is 250, right?
yes.
Okay. 96, 39 is like the type of the steel. Correct.
In the old model, what number of they use? 96 number?
Need to check if he did give detail or not. It is, he used 32, diameter 32. And the steel, I don't know what's the type of the steel because he did not put any name. But we can just take the properties from the old model. Okay.
Yes.
So here, it seems that I need to create a new one. Making it from the old model will not work very well for us. So here, what I can do, click on F8 and I hide one layer from the outside. Okay. Wait, let me make sure it is correct. 1, 2, and then rotate like this. Here also, 1, 2. Okay. So I go to element mesh, element generation, beam, beam by edge. Okay. So here create 1, 2, 3, and 4, and then create, accept. Okay, done. Now again, I will do the same trick, F8. Again, 1, 2. I hide another layer. And then I go again, element generation. Okay, no problem. I will just make one because I can copy later, which will be easier. Okay, now if I go to F8 on blank all, now I have the reinforcement inside it. Okay, how to, let me, this one, Pierre, transparent. Okay.
The size like triangular.
This is because I have not defined the diameter yet.
Okay.
Okay. So first I will go with this stir up or the confinement. The confinement is diameter is 30. Okay,
30,
the diameter is
30.
30. Yeah. So if the diameter is 30, I can go to here. This is part number 15.
The second one is the stirrups.
Number 15 is the stirrups. This is the longitudinal rebar.
Yes, the longitudinal.
So this one, I will make a new section, say section number, let's say 15. And the diameter is also, the diameter is 30. This is stirrups. And then accept material also. I think I will just use the same material as the original model. Okay, so now if I hide this, you can see now it becomes circular.
Yes.
Okay, now I will go to here, element tools, transform. I will translate and make a copy, translate in the Z direction. And the length is 400 mm, so it'll be 0.4. I need to make a lot of copies. I do not know how many copies I need actually. So what I can do, I will make 100, and I can delete the extra. Click by part, select here. Okay, 100 is too much. 50. Okay, 50 is just nice. And then accept. Of course, I will delete the extra ones. Now, if you look at the pier, at the top surface, I have the rebar, which is not correct. So the first layer here on the top, I need to delete it. So I go to element edit, delete, and here delete this one. 1, 2, 3, 4. Okay, you can see it is highlighted. Delete, accept. Okay, now I go to now I go to model, keyword, and I go to beam, and then go make a new section onto rebar. And here is, oh, it is also 30. Diameter is also 30, so I can just use the old one. I do not need to make a new section. This is stirrups number 1, and this is rebar. And you can see it becomes small now. Okay, so here I click on the top view.
The distance between the stirrups is 400.
Yeah, but before I do that, I need to relocate this in the correct place. Okay, because this is too much, so I need to make it at the right place. So if I measure from here to here, this is the distance, 0.25, 0.25. So I go to element, copy. I will make a one copy first. And we have 0.25 and 0.25. XYZ minus, and then here 0.25, and here is 0. Now, if I click on, it will be positive. Okay, it is exactly here on the center. So it is overlapping. So what I can do, first I will delete the initial one, delete this. And then I go back again to this tool. Now I will move it just a bit to remove the overlap. 0.3, 0.3. No need to make a copy. Click my part number 16. Okay, now it is perfect. All right. So now what I can do, the distance is how much? 250.
Yes,
So here I will move to X, 250, make a copy, Maybe I have 20. I'm not sure. Collect by part number 16. Okay, I need a bit more. 25 and delete the extra. Okay, this is fine. Okay, you can see we have extra here. So what I can do, I will delete later. But first I will go to scale and then scale this one, select this node, part number 16. So I'm scaling down to make this one inside. So I put 1.0001. This is too small number, no difference. Scale like this. Okay, perfect. Now I will delete the extra. So delete the elements and accept. Okay, now we are almost done.
Yes.
Okay, from the right view, since we are deleting, I will delete this one extra ones by elements, area, highlight this area, elements inside the area will be deleted, except done. Okay, now again go to the top view. Okay, it's here, hide the cap. Okay, now I can move this to the other side. I can go to here, stir up. No, it is a rubber, but here, show the mesh. And then I go to reflect normal to Y. My center is here, and then copy by part, and part number 16, select, and then make a copy, and then accept. All right, so this one is already copied.
Okay.
Okay, now here I will measure the distance again from here, from here to here. Distance in X is this one. And now I go to transform and then translate in the Y. This is the distance. And I will try 10 copies first. And I hide the stir ups, select by node, make an area like this, and then translate negative. Okay. So we can see that this distance is not correct. I'm not sure why, but that's fine. 10 elements is not good. Maybe I will make it a bit smaller distance. Even a bit smaller. No, this is too much. Okay. So only 9 elements are needed. Okay. Accept. Now again, I go to the reflect tool. The origin is okay. Select the nodes here and then make a copy. One copy is enough. Wait.
To the right side, Y direction.
Yeah, correct. Yes, correct. X direction.
Yes.
Select here, reflect. Okay, accept.
Done.
Okay. Oh, I forgot to make a copy. So again, okay, if I do not make a copy, it will just move and it will not be copy paste.
Yeah,
Okay. So now this is complete.
yes, it's done. So the bar
It's
duplicate
30
node is
mm. Sorry?
The duplicate node is here in the bridge deck.
Okay, everything is connected. The bridge deck is already, I did that. So everything now is fixed together. For the rebar, we need to do this keyword, constraint Lagrange in solid. This will define the connection between the rebar and the pier. Okay?
Can you just select on a mesh?
And then what?
Yeah, see the connection is it cannot be in the deck, in the bridge deck.
Yes?
This one.
Yeah, this one.
Yeah, it is connected.
Yeah,
The
it's
elements,
connected. So
the element size is a bit different, but yes, it is
yes.
connected.
So the element size will not be create any matter.
Not any matter, because you are focusing on the what you call it, on the pier.
Yes.
Okay, so the pier is the most important one.
Okay.
Okay,
Later we will just hollow the bridge deck.
yes, we can do that. The thing is, if I make it hollow, then it will be difficult to make it full again. It's possible, but it will take few steps.
Okay.
So here I will just make a copy, and then I will show you. We can just element edit, element tools, element edit, and delete this one. Delete like this, and delete like this, and apply. Done. Okay. Yes.
It's almost done.
Now we need to make this to the other side. So transform, translate. The distance was 80. From center to center, it was 80. So, and then make the copy, one copy, select part 15 and 16. And then translate negative y. Now it is there. Okay, now the reinforcement is there. Okay.
Good now.
Okay, so let us see the material model. What did they use? Part material model of number 4. Number 4 is solid. Okay. We use this. Okay, no problem. Mm. And this is number 3. Okay, this is for the pier. And in his case, number 6. Number 6, he also used elastic concrete. Okay. And the rubber is number, his rubber is number 6, number 5, DK. DK he used, oh, he used rigid, which is not actually correct. Okay, that's fine.
You can change the correct to the correct one.
Yeah. Okay. So here, elastic concrete. So this is for the foundation, for the pile, and for the girder, for the deck. Okay, so here, bar cap, I can make it number 11. And cap is solid elements. Accept. And wait, why can I? Okay, and pier number 10. Okay. All right. So here, solid, new, make it number 10. And then accept, solid, accept. And this number 10 is for the pier, okay. For the deck, I need 15, and this is for the deck, solid 8, integration point, solid, accept. For the beam is already done, 15 and 16. And for the pad, okay, section is done. Okay, I will just renumber everything. So for the pier is number 10. I change the ID to make it easier and less confusing. This is rebar. In rebar, we have number 15. This is mass. Ship mass. Okay, just leave it as it is. Elastic, concrete, this is for the cap, and for the deck. Cap is number 11, so make it number 11. Simplified or linear model. Okay. So here, rigid. This is also new. And for the rubber, what's the name of the part? Bearing pad.
Bearing pad, yes.
Bearing pad. Did he give the material for the bearing pad? No. This is elastic modulus. This for the barge. Selected for another. Okay. What are the properties then? Okay. Here, bridge, bearing pad, elastic modulus. Okay, so here is. I do not want the here.
You want what information about what information?
Yeah, elastic modulus. Okay, let me search here. Made of rubber. Okay, mud elastic. Software. Where is the details? He did not put any numbers.
You can check about the old model.
The old model, they use the properties of the steel. And they use rigid material. Okay, you can see here in the old model, it is DK. You can see DK, they use material number 5, which is the material of the steel.
But in real time, this is made by elastomeric plastic.
Yeah, that's what I'm looking for. Okay, plain and laminated. Maybe we can find it here.
You are searching for the properties.
Yeah, I just want the elastic modulus or the young modulus. That's all what I need. Here we give the shear modulus.
Ask Chat GPT.
Okay. Yeah, you can ask, and I also ask. Where is it? I have I've asked him before. So let me check.
The Young modulus
Okay.
of elastomeric bearing plate.
Yeah. What is the Young mod modulus of bearing pads used in bridges? 12 megapascal. Uh, well, laminate it.
It is between 1
Laminate it.
megapascal to 10 megapascal.
10 megapascal. Okay. We can make it 25 megapascal. I'm not sure about these values, but we can just make it 25 megapascal. So here elastic, and then new, and then we have the numbers. Oh, we already have it here. So it is 25 e power of 6. Yeah, modulus maybe 0.4.
You assume how much Young modulus?
25 here, 25 megapascal.
Okay.
Density 1.5. 1.5 is equal to 0. And then accept. Okay. So this is done. Material is done. Here is solid. Here is pier. The cap is solid. Here is also concrete linear model. And here the piles is also solid. And here also is linear model. The pad is this one. And pad is solid. And here is 13. The deck here is this one, and linear concrete model, stir up, and this is done. Okay, so here it's done. Everything is connected. We just need to define the contact and everything.
Ship.
Yeah, the ship. First, I will delete this. Okay, and then delete all the old models. The old bridge is done because we have the new one. And then we have these guys. The span here is 15.
In the paper, have you seen the ship have some extra, like mm, they use some trusses in the ship.
Yeah.
Can we use?
The thing is, we do not have information about that. As I already mentioned, we do not have enough information about these trusses. Okay, he used the trusses, but he did not give any information. Like, uh, wait, here, uh, Yeah, the trusses, like the diameter. He did not put any information about the diameter of the trusses or the cross-section area.
Yes.
So we cannot replicate this one if it doesn't have any information. 11 meter, 0.25. Yeah. Is an odd one.
What you are looking for?
The information that I just said. You're with me, brother. I'm telling you, you're asking me to do this. I'm saying, yes, we can do, but we do not have enough information.
Okay,
Like
okay, okay.
we do not have the diameter of these trusses. Okay. If we have the information, then yes, we can do. But we do not have enough information to make this shape. Okay.
Can we see from net?
Sorry.
Can we see from internet or from the ASTO guideline?
9 and 10. Yeah, I cannot do this. Okay, anyway. Oh, I closed the thing that we were just opening. Here the one like this, and this is the thesis. Okay, so what I can do here, the diameter of that trusses or the cross section can be decided later. Right now, I will just do the shape that the information what we have right now. Okay. So here, what I will do, again, I will go to the first tool that I showed you just now, and I will delete everything and start to make the barge. Okay. So here I will delete. And next, I will see here, it's the height here is 4 meter. So from 0 to 4 meter in Y. So that's the first line that I will make. Okay. So here, from 0 to 4 meter. Okay. And then from here to here is 6.5. I can make 6, but I cannot make 6.5. Spacing. Okay. From here to here is 4 meter, right? This is, wait, sorry.
There is also some guideline about ship.
Sorry.
There is also about some guideline in the about ship structure.
Yes.
In the in the ASTO they recommend some ship design. Do you want to see?
The thing is, brother, I was opening this one. You're talking about this one, right? You're talking about this one.
Yes.
Yeah,
Yeah, they have also some ship design.
I was opening this one already just now.
Yes. They have also some ship guideline.
Yeah, but the information that I want is not there. This is just about the math.
Yes. because we have to damage the pair, so to completely destroy the bridge pair, so our ship will look like some cargo large ship.
Hmm. Okay, so how to proceed?
Yeah, you can proceed.
The thing is, even you don't know what to do. That's the problem.
Actually, this is the big problem.
Yeah. Okay, so here again, I make it 0.6. And wait, I can just put here, pick this point, key in 6.5. This will be 3.4. Wait. Okay, and then this one from here to here. Okay, so I think this is complete now. I mean, just the first portion of it. Uh, yeah. So now the rest we can make it as rigid, and we can add the mass, and it will be 53. That will be easy. The height, this one is done already. The width is 11. So you just need to remember that the width is 11. So where is, oh, it is, we need to rotate it later. Okay, no problem. Now what we can do, we can go to, this one will be, wait, how it will be just the shell, right? Yeah, it will not be empty inside. Okay, no problem. I can go here, element edge, create the edges. First, I make it green. After I make it green, I can uh, check the element size. So if it is 0.5, it will be like this. Let me check. Here is maybe 2.5.
You can just see about the ASHTO guideline, the page number 25. There's also some dimensions.
Brother, you want me to follow the paper or follow the guidelines?
The paper also follow the guideline.
Yeah, but the guideline that there are more than one case, right? More than one ship.
Yes. Just for your information, I just page number 25.
25.
25. See, yeah, this one. See, this is the open hooper, covered hooper, decker, jumbo oversize. They have also some guideline and about the as per capacity.
Okay. But anyway, we'll follow the paper
Okay.
because the deck is also from the paper. The pier is from the paper, so we follow the same size as in this one.
Okay. Okay.
All right. So here is element size 20. That doesn't look like 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. But here, okay, I just click here, compare with the paper. Not bad, except All right. Now what I can do, I will make this element generation shell, and number 18 is fine. ID number 8 shell by edge drag, and then 11, and then we have 0.2. Drag in the Z first, click by edge, propagate 1, 2, 3, and 4. Uh, segment 10. Okay, 10 is too much, too small, maybe 30, 40. Accept. Okay, should be like this. Now I go to element transform 11, move in the Z by part, make a copy, translate positive Z, accept. Now I go to uh, duplicate nodes and then merge the nodes, accept. Okay, now I can go to back here. This is 53. So I go again here. I make 50 transform 53 in the X. Click by elements, propagate, and then negative. I have it here. Okay, next. Again, I go to this one. It was, how much was it? 53. So 53. And then I select by edge like we did just now. Not here. 1, 2. And here 1, 2. And create in the negative X. Okay, number of elements. This is fine. This will be rigid. So again, I go to duplicate nodes like this, merge, and then accept. Okay, so here we are done. We just need to rotate it to the right direction. And maybe here I will go to move copy and make it 17. This is barge, or the front part of the ship. No, by part. Oh, not this one. I need to hide this by area element. This one will be barge. And number 18 will be ship rigid. And it will be this and this. By area like this. Apply, done. Okay. So here I have this and this. Now I need to just show or just rotate and position this in the right direction. So transform, rotate by part number, this one and this one, and rotate in the X 90. No, I do not want it to go down. The position maybe somewhere here, like this. Okay, accept. Now translate by part, this one and this one. No need to make a copy. And 1 meter. Okay. Maybe make it in the Z, make it a bit lower. Okay. Now here part number 19 delete. And here Wait. This is the barge. Yeah, so 1 and 15. So this is section number 1 and 15, except. And number 2 is 2 and 2. So 2 and 2, except. Okay. So here I control S to save. Now if I go to move copy or go click on F4 and then the mass by part, the original ship is 2000. This is in kilogram. So it is 2000 ton. This is the original in the mass in the old model. Now in our model, it's half 500 ton.
Yes.
Okay.
We will also collide different ton.
Okay. All right. So now, before I do that, I will just do what you wanted to add the rebars. If although we do not have the information, I will just add more or less something like this. And we have here. Okay. So what I can do here, first hide this. F2, hide this one. Then F. And then F8. Click on F8. And then I will show only this. Okay. Now I go to elements, element generation. Again, beam. And how does it look like? It is like this, and this is going vertical. The one going vertical cannot be done that easily. Okay, I need the top one. It's like this. Okay, so here, beam by 2 node set. And here I have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 32. So maybe 16. 3, 3, 3, 3, 3, maybe somewhere here. Oh, sorry. Clear node like this from the right view. Okay. And oh, sorry. No. Clear node set number 1. Click here. And node set number 2 here. Then create. Okay, now done. Again, node set number 1. Click here. Node set number 2. It's somewhere at the bottom here. Create. Accept. And node set number 1. Click here. Node set number 2. Click approximately here. Oh, sorry. Node set number 1. Node set number 2. Okay. It's not that straight, but that's fine. Okay. So we have the properties, but we do not have the information of that rebar. Okay, so here, this is for part number 19, new. barge reinforcement. So maybe I will make it 120, 120, accept. And then here what we can do, I can go to move copy, part number 19, click my part, and click select 19, 20, 21, then apply. Okay. I think before I apply, I need to split this. Okay, I need to make the elements a bit finer. So split the beam. This one, I will make it maybe 5. Make it 15, yes. And this one, make it 10. And this one, make it maybe 30. Okay. And next, I will move it in the Y direction and making a copy. And then here I need to count because I do not know how much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we, oh, it is here. 1, 2, 3, 4, 5. It's not similar. Okay. I think that's fine. It does not have the same distance. I thought it is the same. So it's not the same. Which is a bit problematic. Tab, we hide this all. Click on F8. F8 and hide this and this. So here we have, oh, sorry, F4, measure the distance, 825. So we will stick with this value. And then, and maybe make it 10. Select by part, select the nodes, select the parts. Still not enough. We make 20 and then we delete the extra. Accept. Okay, now move copy. This is reinforcement. Barge process. Apply. And here, number 19, section number 19. Material is rebar. Okay, it's almost done. Now I will delete the extra. So I will hide everything, just show these two or these two. Click on the top view and then element edit, delete this. Okay. How can I make it same now? Make everything like this. Okay. Transform. I just want to rearrange this to make it a bit nicer. Wait, but okay. Move. Oh, Okay, this is too much actually. One element is 275. 275. Oh, I need to delete that one. Yeah, this one should be deleted. Okay. Now I just need to rearrange this to make it better. So here, click by element, make an area. Oh, sorry, unblank. Unblank class. Transform. Like this. Part, delete, remove. Okay. Oh, sorry. Element. Part, remove the part. And then
Second.
uh, something is wrong here. We do not have an element here. I think I mistakenly did something not good.
Delete.
Yeah. This is annoying because we might need to redo some of the steps. Element edit. Why I do not have the elements here? Split shell, and like this. Okay. This is a problem because it follows that one. By part, select this. No, sorry. It was already merged. And
Your LS Dyna skill is more than good. Who invented the LS Dyna?
it's okay. I do LS Dyna for a living, so it should be understandable.
Who developed
Now,
LS Dyna is nothing in front of you.
okay, I think I made a problem here. F8, unblank all. Yeah, these nodes have been deleted, so I need to redo again. Unfortunately, just redo part number 17. This one also are shifted ugly, so need to delete them as well. So element generation, shell, okay. In the negative y, no problem. 1, 2, 3, and 4. Huh? Was 11, was 30. Eleven divided by this was 40. Yeah, 40. Okay. Mm-hmm. By part, select this one. It was multiplied by 4, 1.1. We put some gap this time, and then um, okay. I think this one need to be a bit. This is how many elements? How many elements we have? 40 elements. So 40 we can divide by 4 and we have 10. So maybe we want only to have 10, but if okay, we can have 10. So here we have 11 divided by, yeah, 1.1 is correct. So here by part, this one, move. And then sorry, 9 is enough. Now should be 9 is enough. And then no need to make a copy. Move this one a bit negative. Yeah, I think this should be fine. And then delete. Oh, this one is also. From here is 53. So unfortunately, this one need to be redone again. And then we have merge. Okay, we merge everything here, except, and then we go to here, shell by H drag, 53, 30, 30 is fine. And then negative X. We had to do a lot of steps, which is annoying. Make it 90, that's fine. Accept. And then hide this. Go to transform, 53 again. In the X, make a copy. One copy is enough. Select the elements, propagate the selection. Negative. Okay. And now I can merge everything. Merge. Okay. And now I have to move copy. Ship rigid. The rigid portion of the ship will be, there will be this one. And also will be this one at the end here. So select by element, propagate the selection. And then we have the barge number 17, which is this. Oh, sorry. Select by part. Apply, done. Okay, this is fixed and everything, meaning they are connected. Just need to delete the additional parts. And here, initial velocity generation, 5 meter per second. In the X direction, correct? And then, what was it? Let me double check here. Okay. And then here, okay. Set, set parts. This is ship. So it is part number 17, 18, 19. 17, 18, 19. Replace set. Segment set. I need to check what are the function of that segment set. Yeah, for the connection, I believe. Yeah, they just to connect between the different parts. So no need. In our case, no need. So I can delete all the segment set. And part number 1 and 2 can be deleted now. Part number 1 and 2 can be deleted. And just for the purpose of documentation, I will make this one number 20. This one number 21. And this one number 22. So from ID number 20, we have the ship. From ID number 10, we have the barge. Sorry, the bridge. Part list, okay. Here, this is ship, 16 millimeter. Okay. This one will be section number 1. Barge, section number 20. And here, section number 22. This one is ship body. Set. Okay. Boundary. This is the fixing of the ground in the original model. The foundation, the piles. And we see here boundary. Okay. So piles bottom. So I need to update this node set to make to put the nodes of the new foundation. Oh my God. Rush. I saved 10 minutes ago. Okay. Last autosave. Good. Open. Oh my God. And here there is no ship yet. But I believe I saved after I made the ship. Okay, good. I have the ship. It's already saved.
We can save. in another file.
Okay. So let me check what was the latest.
We have to change again.
Hmm. Yeah, this one is not that useful. We do not have the ship. So this is the one that we need. But again, here I need to redo this one again. So here, so you should be able to do it yourself after this. I've been repeating for quite some time now. So what I want to do is delete this one and this one, this and this, and also this. And I will just show these two. This also need to be deleted. Okay, so here element generation, and then so shell, edge drag, this one and this one and this one, and this one. Here it was 11. It was 30 or 40, I do not remember actually. And try 40. Create in the negative. Yes, this is correct. This is the correct distance. So hide this. We have some undeformed or some elements which was deformed. Need to clean up model. And then I have this truss. Top view again. I need only one of them. Delete. And this is the distance, I believe, by part. No, move in the Y, negative, and then select again the same part. And then we said we'll make 10 copies or 9, I do not remember. And the distance was 1.1. Make a copy, yes. Now I need to delete the ones on the edge. The one that is overlapping with the side surfaces. Select this and select this. Okay. So this is done. So I go to this. I will make it barge. Like this, like this, like this, like this,
Save the
like this.
project time to time. Save the project time to time. So we'll never
Yeah.
repeat.
Okay, so this is done.
The
Uh,
outside
but
bar will not affect.
it will not affect because it is treated like a single line.
Okay.
Okay, it has also like this and also like this. So here they have more elements actually. Beam by edge. So it'll be number 19. Here also they have elements. Okay. And here also they have some elements. Okay. And then we have just to make sure it is fixed, merge. Yeah, we need to make sure it is merged. And then transform translate number 53. 53, come on. And then here like this. One copy is enough. Should be in the X direction. Move copy. Make it ship rigid. So by elements, click here, apply, done. And then we go to element generation, shell, by edge drag 53 and make it 60 elements. Doesn't matter much. From here to this one to this one, and this one to this one. It will be in the negative X. 90. Okay, so move copy. Ship rigid by part. This is the one. And also this is rigid. It's also rigid, yeah. By elements like this. Save. Okay, so already saved. Now we were like cleaning up the model when that error happens. So here I will delete the extra parts.
Also save the project.
Yes, I just saved rather. Here is ship barge. Will be, let's say 20. 22. Ship body. Accept. Material number 2. Okay. It's not a good option. Ship must should be here. And 0.3. So the shape is fixed in Z. Fixed in Z meaning it's 3. And this one will be 22. Save. And then part will be 20. Part truss will be 21. Ship rigid will be 22. This will be 21. Number 4, I do not need it. Delete. So we delete. So this is delete. This is delete. and then set parts. This is ship, and we have replace, accept, done, save. Node set just now where we stuck. Node set number 1. So I just delete it first. And then create file bottom. Look from the left. Select by area. Select the node by area like this. And apply. Okay. So this is rebar, and this one should be pair. Pair reinforcement. Set, done. Here set parts. This, let's say, make it 20. And new, let's say it will be 15. This is 15 and 16 and 0. Replace. This is reinforcement. Again, back to Lagrange and solid constraint. So this is number 15. In number 10, accept, done. So save, delete. Okay, we have cleaned up the model. Contact, we do not need all of these. Single contact, let us see what's inside here. We can just wait. Tide break, this is no need. This is the original contact. Okay, so this is no need. Surface to surface. This is 1 and 3. So here I would say pier and barge. Pier, barge, contact. Efficient. And then the other contact, I do not need it. Boundary, control damping, database. History node, no need for this. Database, D3 plot. Initial velocity control. Termination, 2 millisecond. Okay. DT2, yes. Mass scaling. Okay, so save. Now I will try to run this and
You put
see.
the
Yes.
you put the slab load and ship cargo load.
Oh, not yet, because it was not there in the model. But let me see first. Okay. Here, okay. To add the load,
of the bridge on the pier.
okay. Here what I will do. So deck material. To add the load, you just need to add this to change this value. 14 concrete deck. Okay, change this value. This is the density. If you change it, the load will be changed.
Hmm.
Uh,
So, so
wait.
uh,
Here is number 14. So right now, if I click on F4 and then go to mass part, so the mass of the deck, everything now, this is the mass. Okay. Total mass
three
is 3,000 ton.
3,000 ton.
Yeah, the total mass
Hmm.
on the bridge. So if you want to increase it, then
Yes.
you go to material, this
Hmm.
one, and you change the density here. So if you want the
Okay.
mass to be double, you double this one.
Okay.
Uh,
My supervisor told me that you can you can assume that how much load and the gravity will be on come on the your bridge to calculate the loads.
so have you calculated that?
Hmm? What?
Have you calculated that?
No, I don't know how to calculate.
How can I help you, brother? You tell me put 1 ton, I put you 1 ton. You tell me to put 50 ton, I tell you how to put 50 ton.
Yeah, but we have to calculate the load. Do you know how to calculate the load?
Calculate the load of what?
The slab load. There is something formula in the civil engineering.
Uh, yeah. Okay. Again, I tell you, I'm not from civil engineering and I'm not bridge engineering expert. You laugh,
Mm.
but you're the one who'll be crying later,
Hmm?
not me. This is your project, and it seems that you're not studying very well. Anyway, so I already told you how to change the mass here. The mass, yes, now we measure. It was 6,000 ton. Okay, if
Yes.
you want to be double, you just double, not this, you just
Not,
double
not,
this value. Okay,
yeah. The density.
yeah, change rho. Rho is the density
Yeah,
to
change
change
row.
the
Okay.
mass of the
Okay.
deck.
Okay. Okay.
Change the
Okay.
load.
Mm. Okay.
Okay, next,
Ship cargo weight.
keep going here again. Change rho to change the total ship mass.
Mm.
Okay, I repeat the same trick.
Digit.
So click on F4 or go to this measure tool, measure the mass by the part, and it
Mm.
has two or more than one component. So you
Yeah.
select all. Now you can see this is the mass, which is 500 ton.
500 ton.
Yeah, 500 ton. So
Okay. You can increase it.
if you want to increase it, then again, you just change this value here. Okay.
Okay.
So
So
since you don't know a lot about formula, I will tell you a simple formula. Okay, you want how much of the mass you want to be?
we can just look about the paper that how much they can collapse the pair.
Okay, this is in the paper. This is the one. Okay.
First they put 1723.
1723, 4,000, 6,000.
Yes.
Okay. So we have three values.
Yes.
So which one?
You can put the load like that they can damage the pair,
All of them damage
destroy
the
the pair.
pair.
Yeah, to destroy the pair. Like
Okay, here it did not. They did mention somewhere that
maybe maybe in the case one we have
okay,
to do.
okay. Here is the thing, brother. Because to save the time, we can find it later. So here I will just tell you an example. Okay,
Mm,
I
mm,
will just tell you an example for the total mass is 1723.
mm,
Okay, or
mm,
I will just pick a simple number. Okay, this one is fine. So this is the target mass. Target mass. So here is current density, current mass. So which we can see from the paper, from the model, sorry. So this is the current mass, and this is the current density. So here we can say target or new target target mass, meaning the mass target density, meaning the density that we want to calculate equal to current density multiplied by target mass divided by current mass. This one in ton, so I need to put it in ton. Okay, so this is the simple formula.
Okay.
So here, current density is 1.834 multiplied by like this, and then divide by current mass 531,414 multiplied by the target mass 1723000. So this is the new density. So I copy this one. I paste it here, remove the comma, accept. So this is the new value. Okay.
The
Now,
ship cargo weight, right?
now if I measure this one, you can see it's almost there, 1.6. So it means that I need to increase more. Okay. And the reason why we do not get the exact value because there are some decimal point and I round up. That's why we get this small difference. So the idea is you can increase it even more. So here instead of this one, I put 9. Instead of 94, I put 99. Accept. Click on F4. Then measure again. Now you can see there is some small difference. 1.93 become 1.94. So from there, that's how you calculate, or that's how you increase the mass.
Okay.
So here I put 6. And here I put 1. Except for F4, measure. So now it's 1.7. So it's almost approaching the value that we want. Okay. So that's how you get the
Now we
target
put
mass that you want.
yes. Now the total weight is how much the DWT? 1,000.
Okay, 1,700 ton.
Yeah, 1,700 ton.
Yeah. So again, you can slightly increase this value slowly in order to get the results that you want. By area, part, like this. So 129. You want 123, 129. You want 123. So here, maybe I will make it 4. Accept, done, F4 to measure 19 or 1715. So here again, yeah, I just need to increase it slowly. Okay, this is acceptable. Okay. So that's, I think that's all. So to change the mass of the ship, you go to material rigid 22, change the flow accordingly. And then to change the weight on the bridge, you go to number 14 and you change the mass. Or to change the load, you change the density in material number 14.
Okay, got it. Yeah. So if we want to change the velocity of the ship,
Okay, you can look here to change the velocity of the ship. You go to initial velocity generation.
yeah, I mean the ship speed.
Yeah, velocity of the ship velocity here, initial velocity generation. You change here.
Now
Okay,
it's
right now,
five. Now it's 5 meter per second.
yeah, this is 5 meter per second.
Okay.
Okay, so
Yeah, it's
no,
done.
sorry.
Yeah, it's done. Continue.
Okay. For my side, everything is done.
Yeah, okay. So now we will, our target is to damage and to destroy the pair and the ship. You noted
Yes.
my supervisor comment?
No, I did not. It was
He,
a
he
very
did.
long voice message. I did not hear
Okay,
all
okay.
of it.
I will explain to you.
You should explain me before, rather not now. Yes,
No, I
explain.
yeah. It said that finally, in the simulation of collision, the current model cannot see the damage area. The bow is not deformed. So
Hmm,
the teacher hopes that you can simulate the collision, the bow deformation, and the bridge is also damaged.
hmm,
Pair,
hmm,
and see the damage size area and the depth
hmm.
of the damage. Yeah,
Yeah.
yeah. This is his comment. Um, like the bow should be deformed and the pair will be damaged. Okay.
Okay, that's for the result. In order
Yes.
to show that, you need to get the result.
Yes.
So here, if you run, of course, it will take some time, but I will show you the results here. The results from your original model. Okay, so here after the impact, okay, you need to hide everything and show only the pier, and then go to post process and show the effective plastic strain. Mm, not sure why it does not have any strain here, but we have some Yeah, we have some very small stresses.
Yeah.
You can go to here and change the range in order to uh, show different values. Yeah, so something like this. You can just play with these two values. So we have some damage in your original model.
Yeah.
Okay,
Yeah. But
so you just need to play with these values to get the right color that you want.
yeah, they showed the damage in the concrete, cracks in the concrete.
There is no
The
crack in the concrete.
Yeah, in this model, there is no crack on the concrete.
Yeah, there is no crack in the concrete because the ship is too weak.
Yeah, so that's why we have to.
So here in this model, we have the reinforcement. So there should be some damage.
Yes.